Hi, I'm Dr. McKay with the University of Cincinnati, and I want to welcome you to Respirator Fit Testing Errors and Solutions. I have more than 35 years experience conducting respirator research, training courses, and most importantly, to this day, personally conduct fit testing on real workers. Have you ever wondered why so many poorly fitting respirators pass respirator fit tests conducted with sweet and/or bitter aerosols? The answer is human errors. These human errors are commonly due to inadequate training, lack of oversight, failure to follow standard guidelines, and simply recognizing that guidelines are not cookbooks either. While technical and procedural errors can affect fit test results, this video will focus on some of the most common human errors. This video will show you how human errors can cause poorly fitting respirators to pass fit tests using the sweet and/or bitter fit test methods. This video will also show you how to identify these errors and provide solutions. This will help ensure workers obtain acceptable respiratory protection. So, let's begin. OSHA says to produce the aerosol, the nebulizer bulb is firmly squeezed so that it collapses completely, then released and allowed to fully expand. But OSHA doesn't tell you how to squeeze the bulb or the speed at which it should be squeezed. Both of these affect aerosol output. There are guidelines by ANSI and ISO on respirator fit testing. They both say, quote, to produce the aerosol, grip the bulb in the palm of the hand, not fingers only, and firmly squeeze the nebulizer bulb so that it collapses completely. Then release it and allow it to fully expand. Neither specifically mentions if squeezed too slowly, little to no aerosol is produced, which can cause a poorly fitting respirator to pass due to an insufficient challenge concentration. So, using the fingertips doesn't adequately compress the squeeze bulb. Let's take a look at a video I've produced to show this in detail. And then lastly, when you squeeze the nebulizer, you need to use your entire hand. That may not have been obvious when you were watching me, but you squeeze with your fingers all the way into your hand. If I use my fingertips, if you watch a lot of training videos, you'll notice they're squeezing it like this. Very little, if anything, comes out if you do that. Let me show you by removing the top. We'll put a little bit more liquid in here. So watch what happens if I just slowly squeeze it with my fingertips. You probably don't see anything coming out. Now, if I squeeze it with my palm, you might be able to see a large amount of aerosol coming out. Again, I'll go with my fingertips. If you use your fingertips, don't squeeze it completely. Essentially nothing comes out. Squeeze it, completely compress it, allow it to completely expand before the next squeeze. So, another source of human error is excessive tilting of the nebulizer.
OSHA doesn't specifically mention that excessive tilting of the nebulizer affects aerosol output. ANSI and ISO do, and they say, quote, maintain the nebulizer in an upright, vertical position when spraying the aerosol. You'll notice the picture at the bottom right where the operator certainly is not holding and spraying the nebulizer in an upright, vertical position. In this example, no liquid aerosol will be generated. So let's examine how excessive tilting reduces aerosol output. I'm going to show you a video, but before I show you the video, I just want to point out to you the bottom of the nebulizer. The bottom of the nebulizer, which we call the well, trying to show here with the arrow at the bottom right of the screen. This is the part where the liquid, you place the liquid into the nebulizer. And then this Q-shaped object here is the jet. The jet is shown isolated on the right part of this slide here. And just want to point out that the jet the bottom of it will sit in the liquid within the well, and by capillary action, it will suck up the liquid, and then when you squeeze the bulb, that liquid will be aerosolized and delivered into the enclosure. If the well is held at an excessive angle, or in other words, it's tilted, then the bottom of the jet is unable to pick up the liquid and unable to generate an aerosol. So let me show you the video of this.
You take the nebulizer here, put a little bit of solution back in it, and this is particularly true when you get towards the end of the test and there's less liquid in there. So there's a pickup on this jet. And if I tilt the nebulizer excessively, I'm going to go ahead and just put the cover on. And you will not be able to see this, but when you get the kit, you can look at it yourself. If I tilt the nebulizer excessively, now when I squeeze it, it doesn't pick up the liquid. You cannot generate the aerosol. If you don't generate aerosol, you have no challenge. If you have no challenge to that face piece seal, then potentially a respirator that does not fit well may pass if you don't deliver the challenge agent.
Another human error occurs in regards to where do you spray the aerosol. So OSHA doesn't specify where to direct the aerosol output, but ANSI and ISO both do. For example, in ANSI Z88.10 Fit Test Methods, they state, quote, insert the nebulizer nozzle into the opening at the front of the hood and direct the aerosol into the void between the side of the respirator and the hood. In other words, don't do what's shown on the right part of this screen here. So what's wrong? Well, what's wrong is that the operator is pointing the nozzle directly into the filter. If you spray the aerosol directly into the filter, that diminishes the remaining aerosol concentration to potentially challenge that facepiece seal. Let's show a video that illustrates this for you.
The other thing you don't want to do is you don't want to spray the aerosol directly towards the respirator filter. So imagine I was wearing this a worker was wearing this respirator and they have the enclosure on. If I take the challenge agent here and if I have it very close to the filter, well, then I'm spraying that aerosol right up against the filter. But you know what? NIOSH has already tested these filters. We know these work. What we want to do is we want to direct that aerosol around the periphery of the face piece and not spray it right up against the filter. That would diminish the airborne concentration. And when you diminish the airborne concentration, then you don't get an adequate challenge.
Here's another example of a fit test being conducted incorrectly. Can you see what's wrong here? Well, the answer is there are two holes on the front of the enclosure. And in this case, the operator is spraying the aerosol into the wrong hole. In this particular example, the aerosol is being sprayed into the hole at the collar that's resting on the worker's shoulders. Above that, and directly opposite the respirator, is the correct hole where the aerosol should be delivered so that you can challenge the facepiece seal. This is not that uncommon. Here you see another example of an operator that is spraying the aerosol into the wrong hole on the enclosure. I'll show you a quick 26-second video of this here.
Some of that testing the team here demonstrated. What they're demonstrating is a fit test. So N95 respirators are required by certain individuals in a respiratory protection program. But to do that, you need to be tested for the make and model of the respirator. So Carol is actually conducting the test to ensure that there's a good seal or fit for Jeanette, who is being tested for that.
So it's really amazing the number of times I've seen people spray the aerosol into the wrong opening. OSHA required exercises for qualitative respirator fit testing are shown on this slide. They include normal breathing, deep breathing, turning the head side to side, moving the head up and down, talking, bending over, or jogging in place when bending is not possible. And then finally, a second normal breathing exercise. The important thing here to recognize is that each exercise must be 1 minute in length. Since there's 7 exercises, that means that this part of the fit test alone will take 7 minutes. When the test is being conducted, initially the operator will administer 10, 20, or 30 squeezes of the aerosol into the enclosure, and this is based upon the previous threshold screening results. Then, because the aerosol is affected by gravity and it is essentially falling towards the ground and no longer challenging a respirator, every 30 seconds, the operator must replenish that challenge concentration. So every 30 seconds, the operator will maintain the challenge concentration by spraying 1/2 the initial number of squeezes used at the beginning of the fit test. And this process will continue every 30 seconds for all 7 1-minute exercises. Keep in mind, qualitative respirator fit testing is the most common method for fit testing healthcare workers since they frequently wear N95 filtering facepiece respirators. But human errors are very common, and they include an incorrect number of squeezes, using exercise times that are too short, in other words, less than 1 minute each, not using all of the OSHA required exercises or modifying them, conducting the exercises incorrectly, or skipping the exercises. Any and all of these errors permit poorly fitting respirators to potentially pass the fit test. The reason for this is simply human nature in many cases. Everyone seems to be in a hurry these days. Total exercise time ends up becoming just 2 or 3 minutes rather than the 7. And unfortunately, the person being fit tested doesn't know the test was administered incorrectly. He or she thinks that the operator will only do the test according to the standards and guidelines that have been developed by OSHA and others. But this isn't always the case. So these exercises are a very common source of human error because the operator may use an incorrect number of squeezes, not conduct the exercises for the full 1 minute, skip the exercises, etc. The point being that if you have an inadequate cumulative concentration of the challenge aerosol, it is less likely to detect a poorly fitting respirator. QualFit software was developed to resolve this problem. The QualFit software ensures that all 7 1-minute exercises are conducted with the correct number of squeezes for each exercise at the proper time and in the proper order. A screen capture of the QualFit software is shown in the upper right of this screen. At the center of the screen, in white, is the test window. This test window identifies the exercise in progress and calculates for the operator the number of squeezes to deliver for each exercise. Below the test window is a timer, and in this case the timer will indicate to the operator how much time is remaining in that particular exercise, and then it will beep and move to the next exercise and indicate how many squeezes of the aerosol needs to be delivered. So basically the software will walk the operator through each of the necessary steps. So some of the benefits of QualFit software are shown on this slide. I'm not going to read them all to you now, but you can pause the video if you want to read them. Or you can go to qualfit.net and see these as well as additional features that are not shown on this slide. So QualFit software is a solution to the exercise problem. The software automates and tracks each step of the fit test procedure and also provides a printed report. An example of the printed report is shown on the right part of this slide. The printed report also complies with all of OSHA's record-keeping requirements for fit testing. So the errors in this video are just the tip of the iceberg. There are many other reasons why poorly fitting respirators may pass a fit test. If you're an operator, I would highly recommend that you take a class to be sure that you're conducting the fit test properly. If you're a respirator wearer, you should consider checking the credentials of the operator so you have a higher level of confidence that the test is being done correctly. Sometimes people only get an hour or 2 of training on fit testing, and that's not adequate to fully understand everything that he or she needs to do to conduct a fit test correctly and comply with all of the OSHA respiratory protection requirements. I have other instructional videos on respiratory protection and in particular fit testing. You can go to qualfit.net and select the Documents and Resources tab at the top of the screen, or go to my YouTube channel. Two videos in particular that you might find of interest is what is QualFit Software? That's a 12-minute video that describes how this software operates. And then the other is a comprehensive training video on qualitative fit testing using the sweet and bitter solutions. This comprehensive training video is approximately 1 hour in length. More information is coming, so keep an eye out for my soon-to-be submitted article that will cover technical, procedural, theoretical, and even more human errors that affect fit test results. For respirator training courses, consider going to my webpage, drmckay.com. A list of some of my respirator training courses are shown on this slide, and you'll notice I have a number of different fit testing workshops and courses that may be of interest. I want to thank you for watching this instructional video. Again, for respirator training course information, go to drmckay.com. For information about QualFit software, go to qualfit.net. If you have a suggestion for additional videos or have a question, email us at roy@qualfit.net. And thank you for watching this video.